Hey guys, so we're actually starting chapter 11 now. We're skipping chapter 10 because it is actually non-essential. It's cool, but non-essential, so we're going to skip it so we can get through everything before the UVU final test. So this short chapter is about acids and bases, which I'm sure you've all heard of, and now we're going to learn about them a little bit more in depth. So on this first page, we're just going to do some really basic stuff, just some characteristics of acids and bases. And a lot of these you might already know. So acids, those that are safe to taste, which is not all of them, taste sour. And you know this from like lemons have citric acid. There's something called litmus paper. There's different types of litmus paper. You have used something that's sometimes called pH paper. Probably you've used that. And if you like stick it in a liquid, it will turn different colors. So there's a kind of paper called a blue litmus paper, and it turns red when you put it in acid. So acids turn blue litmus paper red. Acids can burn your skin, again, depending on the type of acid and how strong it is. Acids react with metals to make hydrogen gas. And we've actually seen this before in the lab. I don't know if you guys remember, there was a lab where we put a little bit of magnesium metal, it was like kind of like a flexible metal, into some hydrochloric acid, and it started bubbling. And the bubbles were hydrogen gas. So metals plus acids makes hydrogen gas. And then last thing about acids is that they dissolve in water, and when they dissolve in water, they form ions. And these specific ions that they form are H+ ions. So that means that they are conductive. They conduct electricity. If you guys remember, ionic compounds conduct electricity. And that's because you've got ions floating around in solution that are conductive. So acids also will conduct electricity. Just to show you what a couple of like common acids are that you might find in your home. The vinegar is acetic acid. Here's the formula. You'll notice there's an H in the formula. Carbonic acid is in soda. Also there's an H in the formula. Citric acid is in citrus fruits, also several H's. Hydrochloric acid is stomach acid, that's HCl. In batteries, you'll have sulfuric acid, also has hydrogen in it. Rust converter, I've never used that, but it's got hydrogen in it, H3PO4. Skip this one. Okay, so just so you know, those are some common household acids. Okay, so bases now. Bases, those that you can taste, which again, a lot of bases you should not taste, but if you can taste them, they taste bitter. They feel slippery, so a lot of bases are cleaners and soaps, so that makes them slippery. They turn red litmus paper blue, so you can remember bases turn the paper blue. They're bitter, lots of words with B. And then bases also dissolve in water. But instead of making H+ ions, they make OH- or hydroxide ions. It's a polyatomic ion if you recognize it. So that also makes them conductive. They conduct electricity. And then bases can also burn your skin, depending again on the type and strength of the base. So again, a lot of bases are cleaners, soaps, baking soda is also a base. So there are some bases around your house also. Okay, that was section 11.1. Really easy, really fast. We need to get through this chapter pretty quickly, so we're actually gonna do 11.2. really quickly now. So 11.2 is all about something called pH, which you probably have heard of. So we're going to talk more about it. So we want, acids are important. They're important in chemistry. They do a lot of things. And so we need to have ways to measure how acidic something is. And acidity depends on one thing, and it is the concentration of H+ ions. And when we're showing concentration, we'll sometimes show it with brackets. So if you ever see brackets and then H+, that means concentration of H+ ion. All right, so things that have higher concentrations of H+ are going to be more acidic. They're going to have a higher acidity. Okay, now we came up with a scale to measure acidity, and as you're probably guessing, it is called the pH scale. So the pH scale is a logarithmic, we'll talk about what that means in a second, logarithmic scale used to measure acidity. Okay, now on the pH scale, it's a little bit backwards. Lower pHs are higher acidity, and that means higher concentration of H+. So you just have to remember low on the pH scale is high acidity. So we're going to draw a little pH scale here. Starting at 14. 14 is the highest number on the pH scale, and it goes down from there down to about 1, or sometimes people will have 0 on there even. Okay, so you probably maybe know that 7 is neutral on the pH scale. So neutral meaning it's not an acid or a base. Pure water is neutral. Everything below 7 is an acid, and it gets more acidic as you go down. So more acidic going down, that means we're getting more and more H+. So higher H+ concentration. As you go up, everything is a base above 7, and as you get higher, things get more basic. And for now, we're just going to say that means that there's a lower H+ concentration. It also means there's a higher OH- concentration. But for now, we'll just talk about H+. So just to put this scale in context a little bit, just wanted to tell you about a couple of normal household things and where they are on the pH scale. So something like toothpaste is a 9, so it's slightly basic. Baking soda is between an 8 and a 9. Ammonia is up here around 11. And there's some bleaches and cleaners that are way up here, really basic. That's why some cleaners are really dangerous. If you go down to the acidic section, milk is actually right here, slightly acidic, like a 6.6. Tomato juice is a 4. Orange juice is a 3. And then you get down to 2 is lemon juice, and then 1 is hydrochloric acid. So another thing that you need to know about the pH scale, it's really important, is that, again, it's logarithmic. So what that means is that as you go down 1 unit on the pH scale, it actually gets 10 times more acidic. So if we go down from a 7 to a 6 is 10 times more acidic than a 7. A solution that's 6 is 10 times more acidic than a 7. So knowing that, how much more acidic do you think a 5 would be than a 7? So if you're thinking 100 times, you're right. So that would be 100 times more acidic. If we went down from a 7 to a 4 would be 1,000 times more acidic. So you can see it goes down by tens. So if I were to ask you how much more acidic is a 2 than a 4, it would be, you'd go down from 4 to 3, that would be 10, and then 4 to 2 would be 100. So you just add a 0 each time. So that's how logarithmic scales work. They increase by factors of 10 as you go down. There's other scales that are like this, such as the Richter scale that measures earthquakes. So like a 7 earthquake is 10 times as bad as a 6, and an 8 is 100 times as bad as a 6. Brightness of stars is also measured with a logarithmic scale. So pretty common to measure things with logarithmic scales. Okay, one last thing we need to talk about with pH. I know this is a lot today, but I know you guys can handle it. Okay, we need to talk about how to calculate pH. It's a very, very simple formula. To calculate pH, you take the negative log. Don't worry, you don't have to know too much about logs. You just have to type it in on your calculator here. So you take the negative log of the H plus concentration. Okay, I'm going to show you how to do this in your calculator. I'll show you for an iPhone style calculator and an Android. So let's say we have an H plus concentration of 5 times 10 to the negative 3. So often your H plus concentration will be in scientific notation. So we need to take the negative log of this number. So the easiest way to do this is in the iPhone, and you don't have to write this down, but I'll just write this down so you can see it. Type in the number first, then do log, and then if you want to, do the negative sign. Okay, so let's just type the number first. 5 times 10 to the negative 3. So here's 5. Remember on the iPhone there's a button that means times 10 to the, and it's this button right here, this little E. So 5 times 10 to the, and then you have to be careful on the iPhone because the the minus sign is not the same thing as the negative sign. So you need to do negative 3, you need to hit this button up here that says like plus/minus. So we've got 5e negative 3. If you hit equals, you'll get 0.005 because that's what 5 times 10 to the negative 3 is. And then just hit log, which is right here. And that is almost the pH, but it's negative, and the pH should always be positive, so you just need to turn that into a positive number. You can either push the negative sign to turn that into a positive number, or just turn it into a positive number in your head. So the pH would be 2.3. Okay, I'll show that one more time on iPhone, and then I will show you on Android how to do that. So let's say our concentration is 1.2 times 10 to the negative 9. Again, we got to type that number in. So we're going to go, and sorry this is kind of blurry, but 1.2 E negative 9, hit enter. Then hit log, and that's the pH, and then make it positive. pH will always, always, always be positive. You should never have a negative pH. Okay, now if you have Android, if you have iPhone, you can turn the video off now. You're done. If you have Android, your calculator will be sort of like this one that I have right here. So what you will need to do is type log first. So find wherever log is on your calculator. Or actually first find the negative. So sometimes the negative is the same as the minus and sometimes it's not. On my calculator it is. I think on most Androids it isn't. But find your negative sign. Push the negative sign. Push log. And then type the number. So 5 times 10, and then you'll have to do the to the button. Negative 3. And you'll get 2.3. Just like we did on the iPhone. So, that's how you would do it on an Android. I know this was a longer video, but good job. You guys are doing really well. We're getting through a lot of information pretty quickly, even learning at home. So, you guys are awesome. Keep up the good work.